Hello, my name is Amber Edmisson. I'm a student at the Louisiana Scholars College at Northwestern State University. My research project focuses on the inhibition of Zika viral replication, a molecular modeling approach. The goal is to identify a compound or several compounds that can inhibit the helicase enzyme of the Zika virus. Some background on the Zika virus. It was first isolated in a rhesus macaque monkey in 1947 in the Zika Valley of Uganda. It is primarily transmitted by mosquitoes, though it can also be transmitted sexually and from mother to fetus. It mostly causes mild flu-like symptoms. However, in severe cases, it can cause Guillain-Barré syndrome or congenital microcephaly. Guillain-Barré syndrome is an autoimmune disorder characterized by ascending paralysis, and congenital microcephaly is when a child is born with a smaller brain than usual. The Zika virus belongs to the Flaviviridae family. It is a positive sense single-stranded RNA genome. It has 3 structural and 7 non-structural proteins, and helicase is the non-structural protein number 3. The helicase enzyme functions to unwind the RNA genome. It does this by utilizing adenosine triphosphate. The unwinding of RNA allows for transcription factors, polymerase, and other proteins necessary for replication and transcription to bind to the genome. Resveratrol is the reference ligand in my research because it has been shown to bind to the Zika helicase enzyme. I began my research by downloading the helicase enzyme from the protein data bank. I needed to prepare this enzyme for molecular modeling because the structure was missing several atoms and had also included several solvent molecules. Following this, I docked resveratrol to the helicase enzyme to determine a baseline binding score between ligands and the helicase enzyme. I did this by using standard precision and extra precision docking. Extra precision differs from standard precision in that it evaluates more variables. I used the docking to create an E-pharmacophore hypothesis, which is a list of 2D characteristics that a ligand should possess in order to bind to the helicase enzyme. After doing this, I downloaded the Acinex ligand library, which is a library of compounds containing over 530,000 compounds. I narrowed down the compounds using phase ligand screening, which utilized the E-pharmacophore hypothesis. I then screened the remaining compounds with high throughput virtual screening, standard precision docking, extra precision docking, and then the structures that remained after extra precision docking, I minimized the structure to get the best binding score. This slide contains the structures of the 6 compounds that remained following extra precision docking. The E-pharmacophore hypothesis contained 5 features. The first feature was a hydrogen bond acceptor, the following 2 were hydrogen bond donors, and the last 2 were aromatic rings. The Acinex ligand database that contained 530,881 compounds was reduced to 60 compounds utilizing the E-pharmacophore hypothesis during phase ligand screening. The phase ligand screening was able to reduce the number of compounds so drastically because the compounds remaining after phase ligand screening must have contained all 5 features from the E-pharmacophore hypothesis. If the compounds did not contain all 5 features, they were immediately rejected from the screening. After phase ligand screening, a virtual screening workflow was utilized to further reduce the number of compounds. High throughput virtual screening reduced the compounds from 60 to 56. Standard precision docking further reduced the compound number by 26. Extra precision docking resulted in 6 compounds In conclusion, molecular modeling identified 6 compounds from an initial library of over 530,000 to bind to the helicase enzyme better than the reference ligand resveratrol. Out of these 6 compounds, compound 1 bound to the helicase enzyme the best, with a binding score twice as strong as that of resveratrol. Further research with these compounds is needed to determine their efficacy in an organism. This slide contains my references and acknowledgements. I would like to thank my family for keeping me positive throughout the research process. I am also incredibly indebted to Dr. Margaret Cochran for her dedication, feedback, and assistance with my research.